Next, the derivative of implicit function using total derivative. So implicit function, and suppose f is the two independent variables x and y are related to some expression. So f of x y equal to 0. So for example, so x cube plus y cube plus 3axy or 3xy equal to 0. So it is an implicit function. This x and y are related by some expressions. So whenever the expression is given like this, we can use partial derivatives for finding differentiation. Differentiation of this implicit function using these formulas. If it is the first order derivative, so dy by dx, can apply this minus fx by fy. D squared y by dx squared equal to minus of this fxx fy square minus fxy, like that. Okay. Find the derivative of x cube plus y cube plus 3xy equal 0. So using partial derivative. So you take let f equal x cube plus y cube plus 3xy. So what is fx? So differentiate partially with respect to x. So dou f by dou x is nothing but say fx. So 3x squared, and this is 0, and then 3y. Is it right? Then fy equal, that is dou f by dou y. So differentiate with respect to y, keeping x as constant. So 3y squared plus 3x. But therefore, dy by dx equal minus fx by fy, which is nothing but minus fx. Is 3x squared plus 3y by fy. So fy is 3y squared plus 3x. You can take 3 outside. So minus of x squared plus y by y squared plus x. So this is the first order derivative. The second order derivative, you differentiate again. So that is fxx. We need fxx. So fxx equal to what? You differentiate with respect to x again. So that is 6x. Then fyy. You differentiate y with respect to y this function. So you may get 6y. Then fxy. Fxy is nothing but what? So differentiate fy with respect to x. So this fy you differentiate with respect to x, you get 3. You substitute these values in this d squared y by dx squared equal to minus of, you may get the second order derivative. So that is minus of fxxy, xx is 6x into fy. So fy is this. So 3y squared plus 3x the whole square, and minus 2 into fxy is 3 into fx is 3x squared plus 3y into fy. Fy is this 3y squared into 3y squared plus 3x plus fyy is 6y into fx 3x squared plus 3y the whole square, and divided by fy the whole square. So fy is this. So 3y squared plus 3x the whole square. So this is the second order derivative. Right? This is the first order derivative, and this is the second order derivative using total difference. To try this problem, so find the derivative of the following functions using partial derivatives. The first question, x power y plus y power x equal to a power k, where k is a constant. And the second one, u equal to x into log of xy. So you find out du by dx, right? Then the third one, y cube minus 3ax squared plus x cube equal 0. So suppose u is a function of two independent variables x and y, and v is another function which is also a function of two independent variables x and y. The determinant, so dou u by dou x, dou u by dou y, then dou v by dou x, dou v by dou y. So which is called the Jacobian. The determinant என்ன சொல்றோம்? The Jacobian value தான் அது, the Jacobian. So Jacobian of, it is denoted by the symbol like this. So Jacobian of u and v with respect to x and y. So Jacobian of these two functions u and v with respect to the two independent variables x and y. Also we can write it as j equal, so dou of u comma v by dou of x comma y. So this is the symbol, right? So it is equal to this. So we can represent this as Jacobian. We can denote this determinant by this symbol or this one. So dou of u comma v by dou of x comma y is equal to determinant. So this is nothing but what? So Jacobian of u and v with respect to the independent variables x and y. Suppose there are two functions or three functions. U is a function of x, y, z, and v is also a function of x, y, z, and w is also a function of x, y, z. The Jacobian of u, v, w with respect to x, y, z. This is nothing but what? It is also another determinant, 3 by 3 determinant. If it is two independent variables, you go for a 2 by 2 determinant. If it is three independent variables x, y, z, there is a 3 by 3 determinant. So first you take u, so dou u by dou x, and then dou u by dou y, then dou u by dou z. And the second variable, so dou v by dou x, so dou v by dou y, dou v by dou z. Now the third one, so dou w by dou x, dou w by dou y, dou w by dou z. So these are Jacobian of u, v, w with respect to x, y, z. So this is the definition. So dou of x comma y by dou of r comma theta into dou of r comma theta by dou of x comma y equal 1. So I can take this as j and this is j dash. So j dash equal 1. So whatever may be any. So this is reciprocal, right? So dou of x comma y by dou of r comma theta into, you don't simply cancel this, okay? It's not like that. You find out the Jacobian of this value and the Jacobian of this, and then you apply this rule, you may get the value 1, right? So this is one property. So another one, if so dou of u comma v by dou of r comma theta into, so dou of r comma theta by dou of x comma y, which is equal dou of u comma v by dou of x comma y. So this is another property. So dou of u comma v by dou of r comma theta into dou of r comma theta by dou of x comma y equal dou of u comma v by dou of x comma y. So this is another properties. These two are the properties of the Jacobian. So we can use this property, we can do on two problems. So if x equaled r cos theta, y equaled r sin theta, then prove that so dou of x comma y by dou of r comma theta and dou of comma theta by dou of x comma y equal 1. This is the first property. You can try to prove this property. First, dou of x comma y by dou of r comma theta. So now, so dou of x comma y by dou of r comma theta. Then definition namakku determinant dou x by dou r, dou x by dou theta, then dou y by dou r, dou y by dou theta. Yeah. X and y are known, right? So x equals r cos theta. What is dou x by dou r? So differentiate partially with respect to r, keeping theta as constant. So this is equal to cos theta. Then dou x by dou theta. So minus r sin theta. Yeah. Then similarly y equals r sin theta. So dou y by dou r equals sin theta. So dou I by dou theta equal to r cos theta. Right? You substitute this value in this equation, you may get so dou x by dou r. So cos theta, dou x by dou theta is minus r sin theta. Then dou I by dou r sin theta. Then dou I by dou theta is r cos theta. So you expand it. So r cos squared theta plus r sin squared theta. You can take r outside, you may get cos squared theta plus sin squared theta is equal to r into 1, so r. So this is the first part, okay. Now the second part, so dou of r comma theta by dou of x comma y. So to take the, remember this result, this equation number 1. So dou of r comma theta by dou of x comma y is equal, so dou r by dou x, so dou r by dou y, dou theta by dou x, dou theta by dou y. So we need an expression r and theta in terms of x and y. So from these two equations, how we can find out r in terms of x and y and theta in terms of x and y? So r squared equal to what? Cos x squared plus y squared. Is it right? So r equal to root of x squared plus y squared. Is it right? Okay. Then theta equal to, you divide these two, so tan inverse of y by x. Now you find out these values. So dou r by dou x. You can differentiate this, and r squared equal x squared plus y squared. Differentiate with respect to x. You may get 2r dou r by dou x equal to 2x. Then dou r by dou x equal to x by r. Right? So what is x? R cos theta. So r cos theta by r. So this is equal to cos theta. Is it right? Okay. Then dou r by dou y. So dou r by dou y equal to, similarly y by r. This is equal to, so similarly dou r by dou y equal to y by r. So r sin theta by r is equal to sin theta. You differentiate it, so dou theta by dou x. So tan inverse of y by x. Differentiate it, 1 by 1 plus y squared by x squared into minus y by x squared. Is it right? You differentiate with respect to x, keeping y as constant. You take LCM, goes numerator. So minus y by x squared plus y squared. What is y? Minus r sin theta by this is r squared. So minus sin theta by r. Is it right? Then similarly, dou theta by dou y. 1 by 1 plus y squared by x squared. Differentiate with respect to y, so into 1 by x. You take LCM and simplified x by x squared plus y squared. So x equal to r cos theta, and this is r squared. So cos theta by r. Now you substitute in this expression. So dou r by dou x is cos theta. So dou r by dou y is sin theta. Then dou theta by dou x minus sin theta by r. So this is cos theta by r. So expand it. So cos squared theta by r plus sin squared theta by r. Then take 1 by r outside. So cos squared theta plus sin squared theta. So this is equal to 1 by r. So this is 2. So from 1. So dou of x comma y by dou of r comma theta equal to r. So this is equation 1. So from 1 and 2 we get from 1 and 2 we get, so dou of x comma y by dou of r comma theta into dou of r comma theta by dou of x comma y equal, so this is r into 1 by r is equal to 1. So this is a required result. The next problem, if x plus y plus z equal to u, and y plus z equal to uv, and z equal to uvw, then prove that dou of xyz by dou of uvw equal to u squared v. The left hand side, so dou of xyz by dou of uvw. So this value is so determinant. So dou x by dou u, dou x by dou v, and dou x by dou w, and dou y by dou u, dou y by dou v, and dou y by dou w. The third one, dou z by dou u, dou z by dou v, and dou z by dou w. Right? Okay. So if we calculate x, y, z in terms of u, v, w easy differentiate. So from these three equations, you find out x, y, z in terms of u, v, w. Right? So from 1, so x equal u minus y plus z. So u minus y plus z value is uv. So u minus uv. So x equal u minus uv. So y plus z equal to uv. So y equal so uv minus z. Right? So uv minus z value is uvw. Yeah. So this x is in terms of uw. VW and y is in terms of UVW, and this is already in UVW, right? So now you find out these values, dou x by dou u, dou x by dou v, dou x by dou w. So dou x by dou u equals 1 minus v, dou x by dou v is minus u, then dou x by dou w is 0. Yeah, so here dou y by dou u, so v minus vw, then dou y by dou v, so u minus uw, then dou y by dou w, so minus uv. Then similarly here dou z by dou u equal to vw, dou z by dou v equal to uw, dou z by dou w equal to uv. We substitute these values in this equation. What will get now? The determinant dou x by dou u, so 1 minus v, then minus u, then 0. The second one, so here v into 1 minus w, so u into 1 minus w, then minus uv. So from this third one, so vw, uw, then uv. Right? Yeah, I can take u outside and u outside. So you may get u squared v. So determinant 1 minus v minus 1, 0. So v into 1 minus w, 1 minus w, then minus 1. Then vw, w, then 1. Right? So you expand it, so u squared into v. You expand with the third column, you may get 0. Then minus 1 into, so plus 1. Yeah. So w minus vw and plus vw. Okay. Then plus 1 into, omit this row and this column, you multiply these two, 1 minus w, then minus v plus vw, you multiply these two, plus v minus vw. Simplifying, vw, then vv gets cancelled, so 1 minus w, so here vw, so remaining, so u squared v, so w plus 1 minus w, so this will get cancelled, so u squared v into 1. Right? So this is the required answer. So in the பாடத்தில் we have proved this result. Okay, dou of xyz by dou of uvw equal u squared b. Suppose instead of u squared b, so we may get some 0. So in that case, we can say that the Jacobian value is 0. Suppose dou of xyz by dou of uvw equal to 0. So we can say that these functions xyz are functionally dependent. If the Jacobian value is 0, we can say that the given functions are functionally dependent. If it is not equal to 0, they are functionally independent. Okay? Remember, if the Jacobian value is 0, we can say about the functions as functionally dependent.